The sun's energy.
Energy.
Wait, do you have Dawn?
No. What you doing?
We got here
by Desiree Kuczynski and
Nicole Rosas. Nuclear fusion.
Nuclear fusion is the process of combining nuclei of small atoms to form more massive nuclei. Fusion releases huge amounts of energy. Nuclei of hydrogen atoms are the primary fuel for the sun's fusion. A hydrogen atom, the simplest of all atoms, commonly consists of only one electron and one proton. Inside the sun, however, electrons are stripped from the protons by the sun's intense heat.
So, two proton hydrogen nucleuses smash into each other and are known as H1. When they smash into each other, energy is released. And it loses a positron in the collision, making one neutron and one proton combined nucleus. It now becomes H2. While this is happening, another collision of two protons crash into each other and fuse to make the same product as the first collision, so that when at the very last step, it will make two H3s to crash into each other to make a helium nucleus. When a hydrogen nucleus 2 and another positron crash into each other, energy is released and makes a helium nucleus, or He3. Two of these helium nucleuses crash into each other and energy is released, making a helium nucleus, He4, which is stripped away from two protons, making only two protons and two neutrons as a product. There is the core, the radiative zone, the convective zone. So the helium nucleus, or the He4, is produced in the core and is ridden on electromagnetic waves and goes out into the radiative zone. During this time, it takes a while for the energy to be released into the convective zone, and so it goes in all different directions. It finally passes through to the convective zone through electromagnetic waves. Through the convective zone, it passes through convection and heat, and it can come out as solar flares, light, or solar wind. The end! All right.